So in this presentation I want to show more of the classic design principles and how they are applied in classical buildings. So you usually learn in architecture schools the design principles of the Doric and Ionic order, but they usually do not make the transfer from abstract orders to realistic buildings. So I want to fill that gap with that lecture. So here you see on my first slide again the 5 orders as I explained in my last presentation. So the main 3 ones are in the middle that you learned before, the Doric, Ionic and Corinthian order. So they always use the word order, but actually it's like not really the correct word, because it's more like a column that has entablature on the top that matches. So the Doric column is evolved from the ancient Greek temples, but what you see here on this slide, that's the overview again from Robert Chitham's book, Classical Orders of Architecture, that I recommended already previously. So the column that you see here is the ideal form, which is based on the Roman Empire's proportion. So the Doric order derives from the Greek Doric order, but what you see here is the idealized Doric order as it was used in the Roman Empire and then later on from Renaissance architecture until contemporary. So the Doric one in the middle has a proportion from 1 to 8. So the diameter of the column is seen as 1, and then it has a height of 8, and the matching entablature with these Metopen triglyphen frieze. And here you see the proportions. So the Ionic column has this these volutes there on the capital, and the matching design also of the entablature. And the Corinthian is seen as the most elegant because also most slim column with a proportion of 1 to 10. And then on the very left is the Tuscan order, which is not really an order, but it's like a very simple form of a column that has a very simple entablature design on top as well. So these are the basic vocabulary. So a column that basically it's a proportion of a column. That means a lower diameter of seen as a diameter of 1, and that's here at this point where the column meets its base. Here it's the value of 1, and then a height, and the capital has usually a height of half a column diameter for all the orders except the Corinthian and the Composite. So the capital has a height of 1 diameter. So and then the entablature matches, and also as you can see here, the height of a base that's built under it, if there is one. So here it's seen as 2.4, 2.7 and 3 lower diameter. So this is the basic proportion system. It's not really an order, it's a proportion system. And here you see what I showed in my last presentation, how it matches together with the arcs. If there are arcs, then they have to fit in this system. And this is again an idealized form of how to fit it in, designed by Robert Chitham as well. So this was not so like static truth that was given and every architect has to copy it. So this is the idealized form of the architect Robert Chitham, who wrote this book, I think 1980s or something. So he studied a lot of previous architecture books, like architecture theory books, and he made like a summary and drawed it. He was a UK architect from 1980s, I believe. So, and here you see the different proportions of the arcs matching the proportion of the column, and always the height of the column fitting the right height of the entablature, and then the arc in the middle. So, and in this lecture you see that the height, how it becomes more slim. So the Tuscan arc, it's very rarely done actually in practical architecture, but the Doric exists. And the previous one you see it without the lower base, and here it's added another base and it becomes more slim. So, and you see the most slim one is the Corinthian one, where then he fit like 2 circles in it. That's already so slim that it's rarely done in practical architecture, but the other 2 on the right side are used. So, and then here's a drawing that shows a Roman building, a real one, but I forgot which one, to be honest. And here you see how it's used in the practical architecture. So the base is again a column here. That's a Doric, Roman Doric column, and it has the matching entablature with the Metopen triglyphen. And here you can see it's a very small base, and the arc is fit in. So that's the combination of an arc and a column. By the way, to repeat, the Greek architecture knew only the columns with the horizontal beam on it, and the arc come actually from the Tuscan Empire. So there was kind of an empire around the city of Rome, which was then conquered by the Roman people. That was the first, the first time they kind of conquered another small kingdom, so the Tuscan kingdom, and they knew the arc, and that was combined by the Roman people together with the Greek architecture vocabulary of the columns and the beams, and was merged as something that you can see here. So the arc from the Tuscan kingdom, which is kind of next to the Roman, so of the city of Rome, the northwest, I think, and that was then merged with the Roman culture and with the Greek architecture. So, and here you see this kind of merging together these elements and fitting the arc into the Greek system of vertical and horizontal elements. And then you add a pediment, how you say that in English? Pediment in English? Pediment in French. This kind of triangle roof coming from the Greek temple, adding to the whole system to design like a like something like a roof. So, and then here you see in the ground floor plan also that it's more like a half column, so it actually just indicates the proportion. It doesn't really carry any load, so the wall itself is already carrying the vertical loads, and the arc functions as a window or opening. And here you see the column is just a half column, so it's really just showing, and that's what it's called actually, tectonic idea. So it shows the vertical loads that are transported within this wall, and it indicates the static system. It is not the static system as in some contemporary buildings, but it indicates the static system. By the way, in the Greek temple, it is the column also carries the load in the Greek classic temple, right, like Parthenon. But here in the Roman, in this example of Roman architecture, it just indicates the static system, and it gives a proportion and orientation for the eyes. So here I want to repeat again the system of the columns and the entablature. So this is the classic Greek temple, as the Parthenon also looks like. And here you see the system of columns and no arcs, only the heavy beam, and another proportion of the Doric column, which was derived over centuries during the Greek culture that we've seen in my last lecture, and it developed to a very clear proportion already. So this is kind of the base. But now in this lecture we want to see how this base is used in many buildings, and you will actually see how it can be applied also to many building types. Even in the 19th century they used these systems that you see here together with the arc to actually solve every new problem of building types, like train stations and subway stations and hospitals and schools. So every new typology that came up could actually be solved using these elements, the Greek and the Roman architecture elements. And in this lecture we analyze a few of them. So the first one we want to have a look at is the Petit Trianon in the Garden of Versailles. So Versailles you probably heard about. That's the big French castle in the west of Paris, so outside of Paris, which was made to the main residence of France. First, the main residence of the Kingdom France was the Louvre in the center of Paris, but then the king wanted to move it outwards the city, outwards the center of Paris, to Versailles. And this is not the castle of Versailles itself. This is a small classicistic palais actually that was built much later. So this is around 1780 I think, or something, or 1760. This is the late 18th century, just before the French Revolution. And this is already actually a classicistic style, but I show that because first of all it's very beautiful, I think. Second, it has a good size as a home. And third, it's famous because it's beautiful, but it shows also this Roman system, the Greek system in a very simple way. So what we see here is the garden facade, and we see again the main column. This is the highest order, the Doric order, and it has a very strong proportion. Why? Because another element you have is the width of the space in between the columns. So there's also in Vitruvius' book already is suggestions how wide these spaces can be, and one that is called oistulus, a system called oistulus. Oi means kind of beautiful, is 3.25 lower diameter. So it can range between, actually when it's like 1 diameter, the columns stand just next to each other. There's also a slide of that in the book of Robert Chitham, and I don't know how much this is, but Vitruvius gives us as a perfect system to use 3.25 lower diameter, which he says is the best between too narrow and too wide. So here it's kind of narrow, the columns stand quite narrow. That makes this kind of a strong strong feeling of this kind of gable. And then we have a quite simple entablature in the classicistic manner, so without a lot of decoration. And we have a proportion system over the whole facade. And what's interesting is this kind of how the lower base is kind of merged with the base of the landscape. So here it plays a lot with a proportion system of this block here, which fits into the base of the whole building. And we have a small Verkröpfung here on the side, and then another element on top, which also has to fit in the proportion system. It's usually a bit higher than the entablature. So when the entablature is around 2 or 2.5 lower column diameters, this one should be then in this case around 3. So here you see this the upper balustrade together with the closed and the slightly opened part should be a bit higher than the entablature, which goes around the whole building. And this building is interesting because on the garden facade the columns are used as full columns, at least the two middle ones, and the ones at the corner are already integrated into in 1/4 integrated in the wall. And then the whole proportion system can be found again on the back side, which is the next. No, this is not the next slide. This is another slide from the front where you can see it a bit more clear how the columns stand. And on the next slide, you see the back side, and the same system is used again, but here the columns are just the pilaster, which is like how you say, it looks like iron with the iron into the wall to make it flat. So it's just as a pilaster to show the proportion system, and it's not a column anymore. So that's actually kind of the main entrance that you can see here. There you can see it's just a garden palace, so it doesn't have a representative entrance. And here the main floor is still on the same height, of course, on the garden facade, but the entrance is lower than the rear garden because the proportion was so important for the architect, so that he actually made this entrance lower. And here's another full level where you can have basically the entrance level, and the main floor it looks like a height of 1.2 floors, but that's the proportion system. And then it has quite a low second floor where the bedrooms are, and then this kind of balustrade on the roof, but there's not really a rooftop that they use, so it's just like to fit the proportion. And always you have the five axes. And the next facade is even more interesting, because here you just have I couldn't find a better picture because it's not often photographed, because here you just have the 5 axes, so you can see the building is nearly square in the floor plan, but here all elements like pilaster or columns are taken away, and you just have the pure proportion of the window to the wall, so the relation of the window to the wall. And you can see only the proportion without the decoration of the columns, and that makes also that you recognize it as a side facade, although they have the same proportion. So here you can see this is the second most important, this is the most important with the column and the most beautiful designed one, and then the hierarchy lowers until this, you see this is the side facade, but it has the same proportion. So the columns still give the proportion of this of this facade, but without being actually there. So the columns are taken away and the proportion system's still there. That's why I show you that building, because it kind of takes away the main elements and the proportion remains. So then I want to talk in the other buildings about combination of arcs and columns, because they are often used, and especially the post-Renaissance architecture, starting from Renaissance until the 19th century. Then in the classicistic architecture around the 1920s, so in the early 20th century, they don't use the arcs anymore, similar to the strict classicism around 1820, so 100 years before. So the strict classicism doesn't use a lot of arcs. Sometimes they do, but not so much as in Renaissance and in the other 19th century, especially the late 19th century architecture. They use these combinations, and what you can see here is a triumph arch in Rome next to the Colosseum. On the right side you see the Colosseum. And here you see what I was talking about, and it was seen on Robert Chitham's proportion system. A Greek column, here the highest order again, the Corinthic order that you see here in the middle, and with a entablature in the right height, so it fits to the rest. Actually this line here is a bit irritating because it makes the entablature look even higher, but actually this line here doesn't really belong to the proportion system. So the column ends here, right? So here's the main element here on the that gives the whole proportion of the system. That's the lower diameter of the column, and then the column should have a proportion roughly around 1 to 10, so a height of 10 compared to the lower entablature, and the column, the capital, should have a height of 1. So that's the main element, and it repeats itself like 4 times, and it's built directly in front of the wall, so it doesn't carry anything. The wall carries the load, same as the drawing we see before. And then there's added the base under it, which is pretty high, actually a bit too high in my opinion, which makes the column so slim and thin. And the entablature goes around the whole building to give it like the head. And then something special happens. A very high block is set on top, which doesn't have any proportion system based on classical architecture. It's just given as the designer wanted it. So it's pretty high, so you could integrate these statues here over the columns, and in between you have space to probably show the... So this building shows like a triumph, right? It's called Triumph Arch, so it shows like winning over winning a war or something. And in these scenes that are displayed here, they usually show the war that happened and how they battled and conquered the enemy. So this is fit in. That's why there's so much space here over the small arcs, and here to show the reliefs with the war, with the battle basically that was fought and then won. And so here you have the big arc in the center and small arcs on the side. So in this triumph motive is called a big arc within at least two columns, and here you have a total 4 columns and 3 arcs. So it's like added, two arcs are added, and the building has no real function. It's kind of a gate, but it actually shows like a triumph winning over an enemy in a war or in a battle. So, and this is the first building I want to show, and it doesn't use the triumph motive yet. That comes next on the other building. But here you see the combination of columns and arcs in another way. So you see the main column here. This is the main element that gives the proportion of the whole building. It's an Ionic column, but it has the volutes on the side. So it's a modification of the Greek Ionic order, which has the column like, how you say, you see them only from the front. So from the side they look different, so like 2-dimensional design. And this version here is quite big because it's from the Renaissance. It's around 1500 or something. That's in Neapel. And this building has a modification of the Ionic order, which is like 3D design, 3-dimensional. So the volutes are like around 40 degrees in the floor plan, not really 45, and they're pretty big. So and the column itself is flat, so it doesn't have any relief on it. So, and this is the main element, and it's used twice with a very small, this is not really a full entablature, this is just like connecting element, but these two columns, the height should be 1 to 9 if it's correct, from the lower from the lower diameter here to the height of 9 until here on the top of the capital. And then the arc is added, and 3 arcs, and this gives the proportion system, so they finish here. And then these 3 arcs with the small columns are integrated in another big colossal order. So it means this is another column which is used just like flattened on the wall again, like a pilaster. And this should be a Corinthian capital, but just a bit like stylized to make it more beautiful or more ornamentic. So this big element here is another proportion system, has a lower diameter here, but the pilaster are usually, they don't become slimmer to the top, they're just usually just vertical, and this have an entasis, right, as I explained before, so they become slimmer, the columns, but the pilaster not. And they have a capital here, and here you see the big, this is the big entablature that has to fit the proportion of these Corinthic pilaster. So if they have a, here's the lower diameter 1, the height of 10, then the entablature should have a height of 2.5, so usually 1/4 of the lower diameter of this one. So this gives the height of the entablature, which starts here, right, and ends there on the base of the balustrade. And this gives another proportion system. So this is the arc system, is the small one, standing in the big one with the double columns on the corner. And the whole building finishes with the entablature of the colossal order here. So this is the end of the building, and then there's a balustrade on top and another base under it, which indicates here like a, yeah, not really a full floor, right? It looks like a half, like a basement floor under it. So, and this building is so beautiful because all these windows are left open, and it's like an open entrance gallery that gives actually the stairs behind it, and it is the entrance to another door which is behind it, so that makes it so 3D and plastic. And but it's as I said, designed of combination of a large pilaster system, Corinthian order, and small columns in the Ionic order in the middle, and a combination of arc and this Greek beam entablature system. Yeah, here was by the way clear. I wanted to explain it on this one, but I forgot. This is Sapienza, yeah. And here it's drawn in a different way, right? As you can see, it was designed as doors before and 3 windows, but it is built, or now it remains, maybe was also modified, as an open gate and just 1 door here. But that was actually the drawing by the architect, which had a door and 3 higher windows and 3 windows here, but it's the same building and the same design. So the arc system within the big system. So another building combines, shows a combination of arc and column. Is the this is actually the Pope Church, the Lateran Church in Rome, Church of Lateran. I don't know how, San Giovanni in Laterano, I think is the Italian name. And this is a very representative facade, where you can see here again a high composite. It's a composite order column, should have a proportion of 1 to 10 on a base, and with the entablature going around the building. This is the main entablature and the pediment, and a very high representative balustrade, double balustrade, a close and an open part on the top, and another small column system in it. So this is the kind of the most representative version I know of combination of arc and columns. This is the church of the Pope, actually, so that means the San Giovanni in Laterano. And so the Peter's Dome is the main church of the Catholic Church, but this is actually the church that belongs to the Pope. Yeah, and so this one we skip for now. This is another system where the three orders are like stapled over each other, like added. So you have the Doric order on the ground with the entablature here, Doric order here, entablature here, the pediment and the base needs to be there because of the pediment here of the triangle roof, and then Ionic order here, the entablature, and another base, and it should be the composite, I believe, or is it the Corinthian? Yeah, the composite order, and the final entablature. So 3 entablatures are like kind of added over each other in a horizontal, in a vertical addition. So it was not really merged; it was added on top of each other, and they have 3 times the arc motif in the middle. So here you have 2 doors on the side, but the big one is always the arc in the center. Yeah, so this is the last building I want to show for today. That's a building in Rome also. I believe it was a private villa. So where they use really like 1-to-1 this arc motif. So they use really like the Roman triumph motif. So you see, so which is the main column of the building? You will guess maybe this one. No, but it's not. It's actually an invisible column that is indicating the height of the whole facade and giving the proportion of this big entablature here. So, but it's as same as the side facade of the Petit Trianon. That's why I showed you in these 3 steps. First a column, then a pilaster, and then nothing. But the proportion system is there. So the main column here is not even there. It's a column that indicates the proportion of this, the whole front facade, so ignoring the one on the side, and gives the height and the proportion of the entablature here, which is very massive, and the main column is not even there. Instead, there's added a smaller system in it, so there's a triumph motif. That means the arc is here, as we saw before, and on the side are 2 small arcs, and within the arc system is built a whole Doric order. So this should be probably the proportion of the main column of Corinthian order, because of the very representative entablature on top. And here is built the lowest order, so the Doric order under. So here's the basic point of the arc, right here and here. It's built the whole Doric order under it, and it has to fit in. So it reaches from the bottom here. This is the lower diameter of the Doric order to the top of the column, which is here, and then the entablature of the Doric order, this is this one, has to meet on the top of the Doric entablature here, has to meet the base of the arc. So that means first, when you design that, you need to find the height of the main column, the probably a composite or Corinthian column, proportion 1-to-10. Then they take the column away and they leave the height of the entablature, which should be around 25% of these. If this is 10, so this is kind of usually 2.5 column diameter. So here column diameter, here 2.5. This gives this massive entablature. Then you fit in the arc. It's a bit like design thing, how it looks like. I mean, there's no clear proportion rule for that. We've seen some examples by Chittem, but it's not clearly given. And then here this point gives a proportion that where the Doric order has to fit in with its base, its capital until here, and the whole entablature having these 3 elements again and meeting this point. And then they're adding the pediment, the triangle roof on top. So and this reaches into the roof zone with these kind of caryatiden here on the side. So this and the whole thing is a villa, right? It's a house for it was a house for living. I don't know what it's now. Maybe a museum. It's quite on the center of Rome. I took that photo when I was on holiday there, and it was, I think, a private villa. And then they built this very massive roof, like same like in the Triumph Arc. So it was the 19th century probably. I assume, I don't know, maybe it's also older, but it's a building from at least after 1500 that used the Triumph motif to design a facade of a private building. So that's there. You can see clearly how you combine the Greek elements and the Roman arc. Yeah. And next lecture I show you about classicistic building, how they are integrated, how the Greek system is used in classicistic buildings. Thank you.